same process that we're going through. All right, now, what am I going to do now? Young officer out there, how are you? And I'm going to now devise a study in order to collect the evidence that I need in order to look at whether or not the null hypothesis is likely to be true or false. What I'm going to do is I'm going to take half the cars at random, and I'm going to say that's my control group. I'm going to take the other half, I'm going to put additive in it. At the end of the week, we will see what the gas mileages are, and we'll have a little data set here, gas mileages, cars that have it, cars that don't have it. And that's the evidence that I am going to use in order to look at the question of interest. What's your evidence look like?
Okay. In the criminal process, we do a similar thing, only we take, what we do is we provide rules of evidence. We have rules in the way law enforcement officers can collect evidence. We have rules in the admissibility of evidence, what types of evidence, for example, is it hearsay? Is it not hearsay? Do we have an eyewitness? Do we not have an eyewitness? Are we dealing with scientific evidence that we need someone competent in that field to be the one that presents that evidence to the jury? Is it evidence that's of common knowledge, therefore anyone can become the witness and testify to that fact? And so, just as we have in the data collection side, tried to make sure that we've leveled the playing field, so to speak, we try to do a very similar thing on this side. So
you produce evidence.
So through rules of evidence and collection of evidence.
And this is normally done by the prosecutor. So the analogy of the researcher to the prosecutor. Okay, after we have our evidence, we are going to submit this evidence to a statistical test. And again, in the course, we study several statistical tests, and the names that you would come to recognize is called a t-test. So if you've had any statistics at all, you probably have studied this. Another kind of test that sometimes we use is called a chi-square test. And they're simply mathematical models that we take this data, this miles per gallon, in two different groups, and we stick it into these. You can find these on the internet. My students in Justice 222, we have places we go and they put the data in, and this test is going to do its magic manipulations, and it's going to come out with an answer that will suggest which of these is the best for us to choose. And what kind of a model do you have?
Okay, just this side, what I consider actually a very similar model. We subject this process to either a bench trial, meaning a trial where the judge is not only the fact finder, but ultimately decides issues of fact and law, or through a jury trial process. But to be short, I'll just put the jury trial itself.
12 people.
Okay.
Okay, I got a mathematical model, you got 12 folks.
Okay.
Less than misdemeanor percent.
Correct.
Okay.
But ideally, they're designed to do the exact same thing.
Exactly. Okay.
To test.
Now, once we submit it to my mathematical model, what we're going to get out is called a p-value. And this p-value is predetermined by the researcher. And in the social sciences, we normally take by convention a p-value of what's called less than or equal to 0.05. Now what that is a level of proof. It says that if the p-value is 0.05 or less, the suggestion is that we reject the null hypothesis and we make a decision, a good ethical moral decision. And that decision would be, yes, Chief, the additive makes a difference. And we're going to assume right now it's enough difference to be null. Okay? So, in stating that, we have a jury. The jury comes back, makes a decision. The decision here for us is in terms of probability levels. How does your system handle that?
Well, I'm going to ask the class, what do you think is the p-value, if you will, in a jury trial? What is the level of error that we are comfortable with.
It's not a
Like
number.
beyond a reasonable doubt.
Yeah.
Okay,
there you go.
there you go. So if I were to label it our p-value in a jury trial would be beyond a reasonable doubt.
Now, I ask you this, my system is much more understandable, right? I mean, you can understand 0.05 probability, but what in the world is beyond a reasonable doubt? I mean, it's a little mushy to me. But nevertheless, that's how it works. It works fine, all right?
Take a look.
So, we have come down to the point where we will have a decision. Now, I want to ask you a question. Let me just ask it, if you don't mind. I'm going to horn in on your side for just a moment. When a jury comes back and says, not guilty, are they saying the person didn't do it? What are they saying?
They could have doubt that he did it.
Or, what else? I mean, they could have doubts, that's right. But they're not. Now, remember, they came back and said the person is not guilty. They could have doubts. But that doubt is based on what?
The evidence doesn't support the hypothesis.
Okay? In other words, could just say that was enough evidence. All right? Over here, if I come back and say to the chief, the additive doesn't make any difference, is that really a correct statement to the chief? Shouldn't I be saying, I did not find reason for the additive making a difference? I never say in science, I never say something is not related.